Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to work out the practice problems from the Arithmetic Reasoning subtest of the fourth practice test on my website. In case this is the first time you've found my YouTube channel, I want to mention that I recently created a small website called ASVABapp.com. There you can take 3 short practice tests that estimate your AFQT score, as well as a long version of a practice test that also estimates your AFQT score. Again, all these questions are from the full-length practice test. In the event you don't want to go to the website to take this practice test, and the link's right here, you're more than welcome to use YouTube to take this practice test. In that case, I would recommend that you pause the video after I read each question, you attempt to work out the question on your own, and then you resume playing the video to check your solution. On the ASVAB, you're not permitted to use a reference sheet or a calculator, so if you are taking this practice test at home, make sure not to use any of those resources. In the description of this video, I'm going to include timestamps that are associated with each question, and next to the timestamp, there's going to be the topic that the question's testing, as well as a link to a video in which I discuss that topic in greater detail. So if at any point you feel as if you need more help, just take a look at the description below, and there you'll find those additional resources. So all that finally being said, let's go ahead and get started with this practice test. All right, this first question says, Rosa and her friends are eating out for dinner. If their bill was $45.80 and they leave a 20% tip, how much will dinner cost them in total? So let's try to represent what's going on here algebraically. We want to find what Rosa and her friends' total bill is going to be. So that kind of looks like this. Total equals, we have their bill, of course, and we want to leave a 20% tip of the bill. So that's going to look like this, 0.20 times their bill. So algebraically, this is what's going on. And in case you're wondering where I got this 0.20, again, the decimal equivalent of 20% is 0.2 or 0.20. So to solve this one, all we do is have to figure out what this is. Again, it's going to look like this. We know what her bill is. It's $45.80. We know we're taking 20% of that for the tip, and I'm going to drop the 0 here. So it's going to be 0.2 times $45.80. All right, so the very first thing I want to do is figure out what 0.2 times $45.80 is. And I'm going to do that off to the side so I don't make any simple mistakes here. So it's going to be $45.80 times 0.2. And as you can see, we're multiplying 2 decimals together, notably 45.80 times 0.2. In order to make this math a little bit easier, I want to get rid of these decimals completely. So I'm going to take this decimal in 45.80 and shift it 2 times to the right. And likewise, I'm going to take this decimal in 0.2 and shift it 1 time to the right as well. So in total, I moved the decimal places in both numbers 3 times. So in reality, I'm working this out, 45.80 with no decimal times 2 with no decimal. And once I work this out, I'm going to take those 3 decimal places that I shifted to the right here, and I'm going to shift them back into the left. So let's go ahead and do that. 2 times 0, of course, is 0. 2 times 8 is 16, so we're going to drop down a 6 and carry a 1. 5 times 2 is 10, plus 1 is 11. Carry a 1. 4 times 2 is 8, plus 1 is 9. Bring our 3 decimal places back in. 1, 2, 3. So we can see that this is 91 or 9.16. And again, we can drop off this 0 since it doesn't affect the value of this. So let's just go ahead and update our little algebraic expression over here accordingly. This becomes 45.80 plus 916. And again, now that we're adding 2 decimals together, I'm going to work that off to the side so I don't make any simple mistakes. So we have 45, 80 plus 9, 16. Since we're adding decimals, we don't have to make any adjustments as far as moving the decimal left and right goes. That said, the very first thing you can do is you can drop down that decimal in place. And now we're just doing simple addition. So 0 plus 6 is 6. 8 plus 1 is 9. 5 plus 9 is 14. Carry a 1. 1 plus 4 is 5. So in total, including the 20% tip, we can see they spent $54.96, which is answer choice D in this case. Okay, so that's that one. All right, number 2 says, if the U.S. Mint produces exactly 1 million dimes every month, then what is the total value of the dimes that it produces in 1 year? So the very first thing you have to realize to do this one correctly is that 1 million is expressed like this. It's 1 followed by 6 zeros, okay? So according to this problem, the U.S. Mint produces 1 million dimes every month. But that said, we want to figure out what the value is of the dimes that it produces in 1 year. So if it produces 1 million dimes a month and there are 12 months in a year, that's 1 million times 12. That means it's producing 12 million dimes every year. And again, you should be able to do this math mentally right here. This is the same as 1 times 12. Again, 1 times 12, anything times 1 is just itself. So 12 times 1 is just 12. 100 times 1 is just 100. And that's what we have going on here. Again, disregard these zeros for a second. That leaves us with 1 times 12, which is 12, and then tack on those zeros once you do that, okay? So in total, the U.S. Mint produces 12 million dimes, and we want to know what the value of that is. Well, money, including dimes, can be expressed in decimal form. A dime is 10 cents, so it can be expressed as 0.1. Okay, so to figure out what the total value of these 12 million dimes is, we'll take 12 million and we'll multiply it by 0.1, which again is the decimal form of a dime. All right, so we're multiplying a whole number by a decimal. To make this math a little bit easier, we're going to take the decimal in 0.1 and shift it 1 time to the right. So this becomes 12 million times 1, albeit with that 1 decimal to shift back into the left at the end when we're done. Again, 1 times anything is just itself. So 12 million times 1 is 12 million. And since we moved the decimal 1 time to the right here, we have to shift it 1 time to the left here. And as we can see, this now becomes this. And we place a comma after every 3 spots. So 1, 2, 3, comma, 1, 2, 3, comma. So this becomes 1.2 million, which as we can see is C. Not a lot of arithmetic in this problem, but that said, you have to be comfortable working with large numbers, as well as the fact that anything times 1 is itself. 12 million times 1 is 12 million. 12 times 1 million is the same as 12 times 1, albeit with those 6 zeros to tack on at the end. So again, kind of a good question to test your ability to work through problems involving large numbers. All right, number 3 says, a man who was driving his new hybrid SUV used 10 gallons of gasoline to travel 180 miles. Assuming conditions remain the same, how many gallons of gasoline will he need to drive his hybrid SUV 450 miles? So for this one, it's going to be very easy to solve it using a proportion. And in case you haven't seen that in a while, proportion looks like this. You have 2 fractions that are equal to each other. And what I like to do is fill in the left-hand side of this equal sign with the information that's given, and then I'll fill in the right-hand side with the information I'm trying to find. So according to this problem, they use 10 gallons of gas to travel 180 miles. So I'm going to write 10 gallons went 180 miles. All right. And what I'm trying to figure out is how many gallons, so I'm going to call that X gallons, will be needed to go 450 miles. Okay. Once you set up your proportion correctly, it's just a matter of cross multiplication. So this is going to become 180 times x. 180 times x is 180x. And then we're going to do 10 times 450, which looks like this. All right, let's go ahead and work this out real quickly. And I'm going to do it off to the side so it's clear. We have 450 times 10. All right, so in 450, there is a decimal. Technically, it's right here. When a decimal's at the very end of the number, it's not expressed. That said, it's useful to know that when you're multiplying a big number by a power of 10. Again, you could work this out by doing this, 450 times 10. That would take you a long time. What you need to realize is that when you multiply a whole number or anything by a power of 10, it takes that decimal and it shifts it to the right according to how many zeros there are in that power of 10. So in 10, there is 1 0. So that means just shift this decimal one time to the right and fill in a 0 as needed. So 450 times 10 is the same as 4,500. Of course, this equals 180x. All right, so now we're just solving for x. So we want to get x by itself now. To do that, we're going to divide both sides by 180. This crosses out, leaving you with x equals 4,500 divided by 180. To make this math a little bit easier, we can cross out these corresponding zeros to make this 450 over 18. And it should be pretty obvious that both 45 and 18 have a common factor of 9. So in other words, I could divide 450 as well as 18 by 9. 18 divided by 9, of course, is 2. And 450 divided by 9 is going to be 50. Again, 45 divided by 9 is 5. And just tack on that extra 0 to give you 50. And of course, 50 divided by 2 is 25. Of course, if we look back at our original proportion, we can see that x corresponds to gallons. We can see that right here. And so we'll go ahead and tack on our units down here. And this says if this guy can drive his SUV 180 miles with 10 gallons of gas, it will take him 25 gallons to drive his SUV 450 miles. So the answer to this one is D, 25 gallons. On the ASVAB, you should expect to use proportions at least 2 or 3 times. Again, this is a very useful technique for the ASVAB. Once you get the hang of identifying problems that you can use proportions with, the math will become a lot easier to do. All right, number 4 says the length of a rectangle is twice its width. If the perimeter of the rectangle is 60 feet, then what is the area of the rectangle? So again, since we're dealing with a rectangle, let's go ahead and draw one as best we can here. And according to the problem, the length of the rectangle is twice its width. So let's represent that. If this rectangle has a width of x, that means its length is twice that, so that would be 2x. And again, in a rectangle, this side is equivalent to this side. So if this is 2x, this is 2x, and this side is equivalent to this side. So if this side's x, this side's x. What's more, we know the perimeter which I'm going to call P, is equal to 60 feet. Well, how do you find the perimeter of a rectangle? Perimeter is found by adding up all the sides. So that looks like this. If we start with x and work our way around this circle I just drew, that's x plus 2x plus x plus 2x. Let's add these together. 2x and 2x is 4x, plus x is 5x, plus x is 6x. And again, we know what P is. The problem told us the perimeter, or P, is 60 feet. So instead of having P here, let's replace that with this 60 feet. So 60 equals 6x. To solve for x now, we just divide by 6. This crosses out here, giving us x equals 60 divided by 6, which is just 10. And in math, it's customary to write the variable for which you solved on the left. So this says x equals 10. All right, I'm going to draw the same rectangle, and I'm going to use this information here to label its length and width accordingly. Again, we know x is 10, and x also referred to the width. So this width is 10, and the length, as I mentioned at the beginning of this problem, is 2x. Well, 2 times 10 is 20. So this is a 10 by 20 rectangle, and this problem wants us to find the area of this rectangle. So to find the area of a rectangle, you always multiply the length times the width, which we now have values for. Again, length is 20, so this is 20. Width is 10 times 10. 20 times 10 is 200. And these were in feet, so this is feet squared. So the answer to this one is 200 feet squared, which we can see is B. All right, so that's that one. Number 5 says, on his way to and home from work, John can ride his bike at a constant speed of 16 miles per hour. If he lives 60 miles away from work, how much time does he spend commuting to and returning from work each day? So right away, you should realize that you have all the elements of the distance formula. Again, the distance formula says D equals RT, where D stands for distance, R stands for rate, and T stands for time. And let's look through this one more time. We know he can ride his bike at a speed of 16 miles per hour. Well, miles per hour is a rate. He lives 60 miles away from work. That's a distance, so that's D. And we want to know how much time does he spend commuting. That's our T. Okay? And let's represent what we have going on here. Let's say this is John. This is him going to work. Again, that's 60 miles to get there. And let's say this represents him returning from work. That's him leaving work and going back home. We know in both cases, he rides his bike at a rate of 16 miles per hour. Okay, so that's what we have going on. That said, we're going to use the distance formula to figure out how long it takes for him to get to work, and we'll just double that since it's the same amount for him to get back home from work. So again, we have distance equals rate times time. According to the problem, distance is 60, so let's plug that in. The rate of speed is 16. Again, that's how fast he rides his bike, and we're trying to solve for time. So to do that, we're going to divide both sides by 16. This crosses out here, leaving us with T equals 60 divided by 16. If you want to make this math a little bit easier, you can divide 16 and 60 by a common factor of 2. 60 divided by 2 is 30. 16 divided by 2 is going to be 8. And again, if you want to make this math a little bit easier one more time, you can divide 30 and 8 by a common factor of 2 one more time. And this becomes 30 divided by 2, 15. 8 divided by 2, 4. Okay? All right, now that we've reduced this 60 over 16 to a simple fraction, we just treat this as long division. Again, this says 15 divided by 4. Okay, let's just work that out to figure out how much time he spends going to work. We're asking ourselves, how many times does 4 go into 1? It doesn't. How many times does 4 go into 15 without going over? That's going to be 3 times, given that 3 times 4 is 12. 15 minus 12 is going to be 3. Now, here's where you have to know how to do long division to get this one correct. You can tack on a decimal and a couple 0 placeholders to keep working this out. And once you do that, you have to bring that decimal up here, and you drop down this 0 here. And the question becomes, how many times does 4 go into 30 without going over? Well, that's going to be 7 times, given that 4 times 7 is 28. 30 minus 28 is 2. Drop down this 0 here. How many times does 4 go into 20 without going over? That's going to be 5. 4 times 5 is 20, so we can see there's no remainder here. So we can see that t is 3.75, okay? And this t is only for the amount it takes for him to go to work. Again, his trip home is the same exact as his trip to work. So to find out how much time it takes him in total going to and from work, we're going to take 3.75 and multiply it by 2. Okay. And again, we're multiplying a decimal by a whole number. So we're going to shift this decimal 2 times to the right to make 3.75, 375 by 2, albeit with 2 decimals to shift back into the left at the end. 5 times 2 is 10, so drop down a 0, carry a 1. 7 times 2 is 14, plus 1 is 15, carry a 1. 3 times 2 is 6, plus 1 is 7. Bring those 2 decimals back in, 1, 2. So in total, it takes John 7.5 hours to go to and return home from work. And let's see what our answer choices say. Again, 0.5 or half an hour is 30 minutes. So this is 7 hours and 30 minutes, which is answer choice C here. Okay, so that's that one. All right, number 6 says the weight of water is 62.4 pounds per cubic foot. What is the weight of water that fills a rectangular container that measures 6 inches wide, 6 inches long, and 1 foot tall? So let's go ahead and make a diagram to see what's going on here. We have a rectangular container, and I'm going to try to draw 3D here for you. We have this rectangular container that's 6 inches wide. So that's right here, 6 inches wide, 6 inches long, so that's 6 inches right there, and 1 foot tall, so that's 1 foot right there. Okay? And that's not drawn to scale, by the way. And we want to know what the weight of water is that fills up this tank. Well, we have to realize that we're dealing with cubics, so we're going to have to find the volume of this rectangular container. And to find the volume of anything that's rectangular, you do length times width times height. That said, we have a little bit of a problem here. We can see that there's a conflict with the units of measurement that we were given. We have 6 inches, 6 inches, and 1 foot. So we can either convert these inches to be in terms of feet or this foot to be in terms of inches. Well, we're given this measurement in terms of feet as well. So I'm going to take these inches and convert them to feet as well. Again, 6 inches is half a foot, so it's 0.5. Okay, so this becomes length. Length is 6 inches, which is half a foot, so that's 0.5. The width is 6 inches, which is half a foot, so that's 0.5. And then the height is 1 foot, so that's just 1. All right, so with that out of the way, let's go ahead and do this math here. This is 0.5 times 0.5 times 1. Anything times 1 is itself, so 0.5 times 1 is just 0.5. So this is 0.5 times 0.5. And I'm going to do that off to the side in case you can't do it in your head. This is 0.5 times 0.5. We're multiplying 2 decimals, as you can see. So we're going to shift these 2 decimals, 1 here for a total of 2 times to the right. So this is 5 times 5, albeit with 2 decimals to shift back into the left when we're done. 5 times 5 is 25. Shift those 2 decimals to the left, 1, 2. So the volume of this rectangular container is 0.25 cubic feet. To find out what that is in terms of weight, we have to take this volume and multiply it by 62.4. Again, the weight of water is 62.4 pounds per cubic foot. In this rectangular container, there's 0.25 cubic feet. So again, this is going to become this 62.5 times 0.25. All right, so we're multiplying 2 decimals, as you can see. So we're going to take this decimal in 62.5, shift it 1 time to the right. And likewise, we're going to take this decimal in 0.25 and shift it 2 times to the right. In total, we shifted the decimal 3 places. So this becomes 625 times 25 with no decimals, albeit with 3 decimals to shift back into the left at the end when we're done. 5 times 5 is 25, carry a 2. 5 times 2 is 10, plus 2 is 12, so drop down a 2, carry a 1. 6 times 5 is 30, plus 1 is 31. And since we're starting multiplication with this 2, we have to bring in a 0 placeholder. 5 times 2 is 10, so drop down a 0 and carry a 1. 2 times 2 is 4, plus 1 is 5. 6 times 2 is 12. Let's add these together. 5 plus 0 is 5. 2 plus 0 is 2. 5 plus 1 is 6. 2 plus 3 is 5. 1 plus nothing is 1. Shift our 3 decimals back over to the left. 1, 2, 3. Let's straighten this out. We got 15.625. That's going to be the weight of this water in this container. And that is 15.6 pounds. So they just rounded this down to 16.6 or 15.6, which is right there. Okay, so that's that one. All right, number 7 says, how many feet will a dot on the rim of a wheel travel if the wheel makes 1,000 rotations and has a radius of 1 foot? So in this case, we have to assume that the wheel's in the shape of a circle. So let's go ahead and draw that. According to the problem, we know its radius is 1 foot. And the radius is always the distance from the center point of the circle to one of the edges of the circle. So that's the radius right there. We know that's 1 foot. The question is, if there's a dot on the rim, let's say the dot's right there, how much distance will it cover if this rim makes 1,000 rotations? Well, in order to figure that out, we have to take 1,000, which is how many rotations this wheel makes. We're going to have to multiply it by the circumference of this wheel. So let's go ahead and see what that looks like. This is 1,000, and circumference is given by 2 formulas. It's either pi times diameter if you have the diameter, or it's 2 pi r if you're given the radius. And in this case, we're given the radius, so we're going to use 2 pi r. So this becomes 1,000 times 2 times pi, and radius, according to the problem, was 1. For the ASVAB, you're always going to let pi be 3.14, but sometimes you'll be told to use 22 over 7. So in this case, we're going to use 3.14. So this becomes 1,000 times 2 times 1 is 2, so this becomes 2 pi. And we know pi is 3.14, so this was 1,000 times 2 times 3.14. Let's go ahead and work out this 3.14 times 2. I already know what the answer is because I do a lot of math involving pi. So this is 3.14 times 2. For the ASVAB, it's going to be helpful to know that 2 times pi is 6.28, but let's go ahead and work that out. Again, we're multiplying a decimal by a whole number. So to make this math a little bit easier, we're going to shift this decimal in 3.14 2 times to the right to make it 314 times 2, albeit with 2 decimals to shift back into the left. This becomes 4 times 2, which is 8, 1 times 2, which is 2, and 3 times 2, which is 6. Bring those 2 decimals back into the left. So as we can see, that is 6.28. So this becomes 1,000 times 6.28. And as we've seen in this practice test already, whenever you multiply a decimal or a whole number by 1,000, the quickest way to do that math is to shift the decimal according to how many zeros there are in the power of 10. And I may not have mentioned this, but powers of 10 are 10, 100, 1,000, 10,000, and so on. As we can see, there are 3 zeros in 1,000. So I'm going to take this decimal in 6.28 and shift it 1, 2, 3 times to the right. So 1,000 times 6.28 is 6,280. So in other words, this dot on this rim will have rotated 6,280 feet in total, which we can see as D. Okay, so for the ASVAB, you absolutely need to know the formula to find the circumference as well as the area of a circle. You're going to see questions involving both more than likely. All right, number 8 says the heights of a group of elite long-distance runners are 160 centimeters, 137 centimeters, 149 centimeters, 153 centimeters, 161 centimeters, respectively. Find the average height of this group of runners. So this is a pretty straightforward problem. To find the average, we're going to find the sum of the numbers. And we're going to divide that by how many numbers there are. So that's going to look like this. We're going to take 160 plus 137 plus 149 plus 153 plus 161. And we're going to divide that by how many numbers there are. There are 1, 2, 3, 4, 5 of them. Okay? So, so as not to make any simple mistakes, I'm going to add these vertically. So that's going to look like this. 160, 137, 149, 153, and 161. All right. So this is 7 plus 3, which is 10. 9 plus 1, which is 10. 10 plus 10 is 20, so we're going to drop down a 0 and carry a 2. We have 6 plus 4, which is 10. 6 plus 3, which is 9, so that's 19. And then we have 5. 19 plus 5 is 24. Plus 2 is 24, 25, 26. Drop down a 6, carry a 2. This is 1, 2, 3, 4, 5, 6, 7. So this becomes 760 divided by 5. You should realize that anything that ends in a 5 or a 0 is going to be divisible by 5 evenly. So I know this is going to work out to be a whole number. But that said, we have to realize that we can regard this fraction as long division. More specifically, we can read this as 760 divided by 5. And now we're asking ourselves, how many times does 5 go into 7 without going over? It's going to be 1 time, given that 5 times 1 is 5. 7 minus 5 is 2. drop down this 6, and drop down this 0. The question becomes, how many times does 5 go into 2? It doesn't. How many times does it go into 26? It's going to be 5 times. 5 times 5 is 25. 26 minus 25 is 1. Again, drop down this 0. Question is, how many times does 5 go into 10 now? 5 times 2 is 10, so 5 times 2 is 10. We can see there's no remainder here, and our average in this case is going to be 152 centimeters, which is answer choice B. Okay, so that's that one. All right, number 9 says, in fiscal year 2020, the Army recruiting station in Hawaii enlisted 600 people. If 25% of the people who enlisted were under 20 years old and 35% were between 20 to 22 years old, how many of the recruits were over 22 years old? So there's a lot going on in this problem. It may be helpful to make a little circle chart to represent the percentages that are being talked about. Again, according to the problem, 25% of the people are under 22 years old. So that looks like this. 25% are under 22 years old. We know another 35% are between 20 and 22 years old. So that kind of looks like this. Again, that is 35%. Question is, what is this remaining percentage that is older than 22 years old? Well, that's pretty easy to do. Again, this pie chart adds up to 100%. We're just going to subtract. Again, let's do this math mentally here. 30 plus 20 would be 50. And then you have 5 and 5, which is 10. So 35 and 25 is 60. 100 minus 60 is 40. That means 40% of the remaining recruits are 22 years or older. And we want to figure out what 40% of this 600 people is. So that's going to be 600 times 0.4. Again, 0.4 is the decimal equivalent of 40%. And we're doing multiplication involving a whole number, notably 600 by a decimal, notably 0.4. So I'm going to shift this decimal in 0.4 one time to the right to make this math 600 times 4, albeit with one decimal to shift back into the left at the end. So 0 times 4 is 0, 0 times 4 is 0, 6 times 4 is 24. Shift our one decimal back in. And as we can see, 40% of the 600 recruits is the equivalent of 240 people. So 240 people were older than 22 years old. So this answer is C, 240 people. All right, number 10 says, in a class of 30 students, 19 are studying French, 12 are studying Spanish, and 7 are studying both French and Spanish. How many students are not taking any foreign languages? So again, there's a lot going on in this problem. That said, there should be a clue that tells you how to solve this one. Again, 7 are studying both French and Spanish. When I think about two groups in which there's overlap, I think about a Venn diagram. So I'm going to make a Venn diagram here to represent this problem. More specifically, I'm going to enclose it with a box. And we need to know right off the bat that we're only dealing with 30 students in total. Okay? And the middle of this Venn diagram represents the number of students who are taking both French and Spanish. That's going to be 7. That's right here in this problem. Okay? That said, we know 19 students are studying French. Well, a lot of people would get this wrong because they would just put 19 in this Venn diagram and be done with it. That's not true. In total, there are 19 students taking French, but that said, 7 of the 19 are in Spanish as well. So this becomes 19 minus 7, which of course is 12. So right here, there's 12 students taking only French, which is this part of the Venn diagram. Likewise, we know there are 12 studying Spanish. That said, 7 of those students in Spanish class are also studying French. So to fill in this part of the Venn diagram, that's going to be 12 minus 7, which is 5. Again, there's only 5 students only taking Spanish, okay? And what this box on the outside represents is the number of students not taking any foreign language. So we have 12 only taking French, 7 taking French and Spanish, 5 only taking Spanish. Let's total that up. We have 12 plus 7 plus 5. That's the same as 12 plus 12, which is 24. So inside these interlocking Venn diagrams, there's a total of 24 students. Well, we know there are 30 students in this class, so we're going to do 30 minus 24. 30 minus 24 is 6, and we can place that 6 in this box out here. That represents the number of students not taking any foreign language. Okay, so that's this one, and that is going to be answer choice D. Okay, so again, a lot of logic to solve this one, but nothing too difficult in terms of math. All right, number 11 says Ethan's current test scores in Calculus 3 are 95, 90, and 83. What must he score on his next test to have an average score of 90? So again, we're working with averages again, and averages are found, as we've seen, by taking the sum of all the numbers that you're given and placing that over how many numbers there are. In this case, we're going to have to make an adjustment to this formula because we're given the average. We're told the average that Ethan wants in his Calculus 3 class has to be 90. So we know the average has to be 90. And that said, we only know 3 of his 4 test scores. There's one here, and one here. We don't know what his 4th test score is, so I'm going to call that X. Okay, so let's fill this in accordingly. We know he wants a 90 average. We know his first 3 test scores are 90, 5, 90, and 83. We want to figure out what his 4th test score is going to be, so let's call that X. And we're going to place that over how many numbers there are. There's 1, 2, 3, 4. Okay? All right, so by solving this equation for X, we'll figure out what his 4th test score must be to have a 90 average in his class. So the very first thing I'm going to do is multiply both sides by 4. This crosses out here, leaving us with 95 plus 90 plus 83 plus X equals 90 times 4. That's not that hard to do mentally. Again, 9 times 4 would be 36. Therefore, 90 times 4 is 360. Okay? All right, so now we just have to solve for X, and we can move all these values to the left. But before moving them one by one, I'm just going to go ahead and combine these. So we have 95, 90, and 83. 5 plus 3 is 8. 9 plus 9 is 18. 18 plus 8 is 18, 19, 20, 21, 22, 23, 24, 25, 26. So we can see this is 268. This is 268 plus X equals 360. All right, so to solve for X now, we're going to subtract 268 from both sides. This crosses out here, leaving you with just X. And let's work this out now. We have 0 minus 8, which we can't do. So we're going to have to borrow. This is going to become 5, and this is going to become 10. 10 minus 8 is 2. 5 minus 6 we can't do, so we have to borrow. This becomes 2. This becomes 15. 15 minus 6 is 9, and 2 minus 2 is 0. So we can see that he must score a 92 on his fourth test in order to have that 90 average in the class. So the answer to this one is A, 92. This is a very common question that you'll see on the ASVAB. You'll be given the average and a certain number of the values, and you'll be asked to find the missing value, and this is how you do it. So expect to know how to do this one. All right, number 12 says, during the holidays, a store offers successive discounts on a computer of 10 and 20% respectively. If the computer originally cost $570, what is the final sales price of the computer? So I've created a video on this, and if you don't follow along with what I'm about to do, just go ahead and watch that video. Again, the link's going to be in the description. But to do this one correctly, we have to take 10% off the original price. That will give us our first discount. And then we're going to have to take 20% off that first discount amount. So let's try to represent what we're doing here algebraically. Again, I'm going to call this first discount is going to be the original price minus 10% of the original price. Okay. That will give us our first discount. And then we're going to find the final price, we're going to take our first discount and we're going to take 20% off the first discount. Okay. So let's see what that looks like. Again, this first discount amount is going to be this. It's going to be the original price, which was $570 minus 10% of 570. Okay. Now let's just work this out. This is 570 times 0.1. To multiply a whole number and a decimal, let's shift our decimal one time to the right to get rid of it temporarily. This is 570 times 1, albeit with one decimal to shift back into the left. 1 times 0 is 0, 7 times 1 is 7, 5 times 1 is 5. Bring our one decimal back in. So we can see that this first discount is going to be found by taking 570 and subtracting 57 from it. And if you can't do that mentally, we can work that off to the side. This is going to be 570 minus 57. 0 minus 7 we can't do, so we're going to have to borrow. This is going to become 6. This is going to become 10. 10 minus 7 is 3. 6 minus 5 is 1. 5 minus nothing is 5. So this first discount is going to be $513. All right, to find the final sales price, again, we're going to use this right here. It's going to be this. Final price is going to be the first discount, which is 513 minus the 20% discount of that $513. Okay. So let's go ahead and work this out now. We're doing 513 times 0.2. Again, we're multiplying a whole number by a decimal, so shift that decimal one time to the right. This becomes 513 times 2, albeit with one decimal to shift back into the left at the end. 3 times 2 is 6, 1 times 2 is 2, 5 times 2 is 10. Shift our one decimal back in. So we can see that this becomes, final price is going to be 513 minus 102.6. And of course, you can work that off to the side as needed. This is 513 minus 102.6. Let's add a decimal here and a 0 here. 0 minus 6 we can't do. So this becomes 2. This becomes 10. Again, drop down your decimal in place if you want. 10 minus 6 is 4. 2 minus 2 is 0. 1 minus nothing is 1. And 5 minus 1 is 4. So we can see the final price is going to be $410.40. which is going to be answer choice A. Okay, so that's that one. All right, number 13 says, during their senior year, all 231 of the senior students went on a field trip to Orlando, Florida. Some of the students rode in vans, which hold 7 students each, and some of the students rode in buses, which hold 25 students each. How many of each type of vehicle did they use if there were 15 vehicles in total? Okay, so whenever you're being asked to solve for two things, that should be a clue that you're going to need a system of equations to do so. And in this case, we're being asked to figure out how many buses and how many vans were used to transport these students. So again, we're going to need a system of equations, and it's going to be helpful if we label our variables. In very simple system of equations, you usually have only two variables, x and y. So I'm going to let x, in our case, refer to vans, and y refer to buses. Okay? So now we have to write two algebraic expressions to mirror what's happening in this problem. Again, we know 15 vehicles in total were used, so x plus y totals 15. Likewise, we know each van holds 7 students, so that's 7x, whereas each bus holds 25 students, so that's 25y, and 231 students in total were transported. Okay? So just like that, we converted this word problem into an algebraic system of equations that we can now solve to figure out what x and y are. We're going to use the elimination method, which means we're going to multiply one of these equations by a constant such that we'll be able to eliminate either the x or y variable. I'm going to multiply this top equation by -7. And as you'll see, -7 times x is -7x plus 7x eliminates the x variable. So that's the strategy we're going to take here. Again, we're going to take this -7 and distribute it here, here, and here. So let's go ahead and do that. This is -7 times x, which is -7x, plus -7 times y, which is just -7y. And -7 times 15 is going to be 15 times 7. Let's work that off to the side. 7 times 5 is 35, carry a 3. 7 times 1 is 7, 8, 9, 10. So it's going to be -105. All right, we're adding this to this equation, 7x plus 25y equals 231. Let's add these together. -7x plus 7x is eliminated. That's nothing. And now we have 25 minus 7. Well, 25 minus 7 is going to be 18. So this is 18y equals 231 minus 105. Let's work this out. 1 minus 5 we can't do. We have to borrow. This becomes 2. This becomes 10 or 11. 11 minus 5 is 6. 2 minus nothing is 2. 1 minus 2 is 1. So this is 126 equals 18y. Divide both sides by 18. This crosses out, leaving us with y equals 126 divided by 18. So that looks like this, 126 divided by 18. Now you might be saying to yourself, this is pretty hard to do. How can I figure this out? Well, let's imagine this 18 was a 20. What can we multiply 20 by to give us 126? Well, that's going to be about 6. Again, 20 times 6 would be 120. So this is either going to be 6 or 7. So let's go ahead and see if 18 times 7 will give us 126 evenly. 7 times 6 is 56, carry a 5. 7 times 1 is 7, plus 5 is 7, 8, 9, 10, 11, 12. Okay? So 18 times 7 is 126 evenly. So this is 7. Okay? All right, now that we've solved for y, which we did right here, we take it and we plug it into one of the two original equations, and then we solve for x. So this top equation was x plus y equals 15. We now know what y is, so let's plug it in. This is x plus 7 equals 15. Subtract 7 from both sides to get x by itself. 15 minus 7 is going to be 8. Okay? So this says, again, x refers to vans. 8 vans and 7 buses were used to transport these students. So that's B, 8 vans and 7 buses. All right, so that's that one. If you're doing decent on the ASVAB, you might see a question involving a system of equations, and you want to get that right because this is kind of like a gatekeeper question. If you can solve a word problem involving a system of equations, that means you're pretty good at advanced math, which means that you'll probably start getting some very difficult questions after you get this one right. So make sure you get these system of equations right. Again, they're the key to getting a high score on the ASVAB. All right, number 14 says, one pipe can fill a tank in 15 hours, and a larger pipe can fill the same tank in 10 hours. If both pipes are used simultaneously, how many hours will it take to fill this tank? So this is a combined rate problem, and I made a video on this. And in that video, I mentioned that you can use a generic formula to represent combined rate problems algebraically. Notably this one, T over A plus T over B equals 1. This T refers to the time it takes both things working together to complete one task. Okay? A refers to the time it takes one thing to complete the task by itself, and B refers to the time it takes the other thing to complete the task by itself. So let's go back and look through this problem to see what we have. This one pipe can fill the tank in 15 hours by itself, so that's going to be our A. Okay? This other pipe takes 10 hours to fill the tank by itself, so that's going to be our B. And we're trying to solve for T because we want to know how much time, or T, it takes both of them working together to fill this one tank. So let's plug this in. Again, this is T over 15 plus T over 10 equals 1. All right, so right here we're adding fractions that have different denominators. In order to add fractions that have different denominators, you have to rewrite those fractions such that they have the same denominators, okay? So let's think about this one. 10 and 15 are both factors of 30. Okay? So I know I can rewrite 15 as 30 and 10 as 30 pretty easily. Again, 15 times 2 is 30, but that said, I'm going to have to do it to its numerator to keep proportionality. 2 times t is 2t. Again, to write 10 as 30, I have to multiply it by 3. Again, 10 times 3 is 30. I'm going to have to do the same thing to its numerator, so this becomes 3t equals 1. All right, let's keep working this out. Now that these fractions have the same denominator, we can just add the numerator, so this becomes 2t plus 3t over 30 equals 1. 2t plus 3t is 5t over 30 equals 1. We're trying to solve for t, so we want to get rid of this 30. Let's multiply both sides by 30. Getting a little sloppy here. My pen's starting to act up. This crosses out here, leaving you with 5t equals 1 times 30. Again, anything times 1 is itself, so 30 times 1 is 30. Divide both sides by 5. This crosses out, leaving you with t equals 30 divided by 5 is 6. Again, this t refers to the time it takes both things working together to complete one task. So if you have a pump that can fill a tank in 15 hours, working with a pump that can fill a tank in 10 hours, it will take them 6 hours working together to fill the same tank. So this one is C, 6 hours. All right, number 15 says the measures in degrees of 3 angles of a triangle are given by 2x plus 1, 3x minus 3, and 9x. What is the measure of the smallest angle in the triangle? So let's go ahead and draw a triangle to see what's going on here. Again, we can draw any type of triangle since this question's not being very specific. And we know its angles are given by 2x plus 1. So let's call this angle 2x plus 1. Let's call this angle 3x minus 3. Let's call this angle 9x. We're going to use the triangle sum theorem to solve for x. And the triangle sum theorem says all the angles, that is angle 1 plus angle 2 plus angle 3, in a triangle add up to 180 degrees. Okay, again, that's the triangle sum theorem. And again, let's call this angle 1. Let's call this angle 2. Let's call this angle 3. So instead of writing angle 1, we can replace that with 2x plus 1. Instead of writing angle 2, we can call that 3x minus 3. Instead of angle 3, we can call that 9x. And of course, this is going to equal 180. Let's combine our x's now. 2x plus 3x is 5x plus 9x is going to be 14x. 1 minus 3 is negative 2. Of course, this equals 180. All right, so we're still solving for x, so let's add 2 to both sides. This crosses out here. This says 14x equals 180 plus 2, which is 182. All right, let's divide both sides by 14 now to get x by itself. This crosses out, leaving you with 182. X equals 182 divided by 14. Let's work that off to the side again. 182 divided by 14. All right, let's think about how we can estimate this to get this, to figure out what 182 divided by 14 is very quickly. 10 by 10 would be 100. So this is going to be somewhere between 10 and 15 right here. And since it's closer to 10, I'm going to start with 13. So I'm going to do 14 times 13. Hopefully that gives me 182, and we'll know that 182 divided by 14 is 13. 4 times 3 is 12, so we're going to drop down a 2 and carry a 1. 1 times 3 is 3, plus 1 is 4. Since we're starting multiplication with this 1, we have to add a 0 here. 1 times 4 is 4. 1 times 1 is 1. Let's add these together. 2 plus 0 is 2. 4 plus 4 is 8. 1 plus nothing is 1. So we can see 14 times 13 is 182 evenly with no remainder. So this is x equals 13. All right. That's not the answer, of course, because as we can see, these angle measures are 2x plus 1, 3x minus 3, and 9x. Well, 9 times 10 would be 90, so 9 times 13 is going to be a huge number. So we know this one's not the smallest angle. This is 3 times 13 versus 2 times 13. So this one is not going to be the smallest angle. Smallest angle is going to be 2x plus 1. So this becomes 2. We know what x is. It's 13 plus 1. 2 times 13 is 26 plus 1 is 27. So the smallest angle in this triangle is going to be 27 degrees, which is right here. All right, so that's that one. All right, number 16 says a barge goes downstream and covers the distance between 2 ports in 4 hours, while it covers the same distance upstream in 5 hours. If the speed of the stream is 2 miles per hour, what is the speed of the barge in still water? So this is an advanced distance, rate, and time problem, and I'll show you why here in just a second. So we're dealing with distance, rate, and time, so we know we're going to use the formula d equals RT. That said, we have two different scenarios here. We have this barge going downstream and then upstream. So let me illustrate that with a little diagram here. So we have this barge, and let's say it's going downstream or with the stream. That means the stream is pushing on the back of this barge to speed up its rate. So if R refers to the rate of speed, we can represent the speed of this barge as R plus 2. Again, we know the speed of the stream is 2 miles per hour. So this says the stream is speeding up this barge. Now, in this other scenario, we have the barge, and it's going the same distance, albeit upstream. So that means it's going against the stream here. Okay? And if you think about it, that means the stream is actually slowing down or working against this barge. So we're going to represent that as r minus 2. Again, the distances are the same, but we know in this case it takes 4 hours to travel this distance, and in this case it takes 5 hours to travel this distance. Okay, so we can use 2 iterations of the distance formula to describe what's going on here. Again, in this first scenario, we have distance. We don't know what that is. We have a rate of r plus 2 times the time of 4 hours. In this second scenario, again, we don't know what the distance is, but that said, we know we have a rate of r minus 2. Again, the stream is working against that barge. We have a time of 5 hours. Now, for this problem, we want to know what the speed of the barge is in still water. But that said, we have quite a few missing variables. We have r and d. But what do we know about d that's going to make this problem easy to solve? We know d equals d. That is, the distance the barge goes here is the same distance the barge goes here. So if we have d equals d, we can actually set up this equation like this. Again, we have the same distances. This right-hand side of the distance formula tells you what d is. So this becomes this. R plus 2 times 4 must equal r minus 2 times 5. And now we've gotten rid of the d. Again, the distances are equal. So now all we have to do is solve for r. And the first thing I'm going to do is distribute this 4 here. So this becomes that times that. So this is 4r plus 8 equals, and let's distribute this 5 here and here. This becomes 5r minus 10. Again, we're solving for r, so we want to get r by itself. I'm going to subtract 4r from both sides like this. This crosses out, leaving you with 5r minus 4r, which is just r, minus 10 equals 8. And to finally get r by itself, let's add 10 to both sides. This crosses out here, leaving you with r equals 8 plus 10, which is 18. Again, this r represents the speed of the barge in still water. And as we can see, r is 18. So the answer to this one is 18. All right, so that's it for this video. I hope you found it helpful. In all honesty, some of these problems were pretty challenging. In fact, if I had to rate this practice test on a scale of 1 to 10 in terms of difficulty, 10 being the most difficult, I would probably put this at a 7 or an 8. So if you felt as if this one was challenging, that's because it was. That said, all the techniques I showed you in this video are applicable to pretty much all the questions you'll see on the ASVAB. And again, that's the most important thing to take away. You want to study the techniques, not the questions. Okay? So if you like the content I'm creating, please consider subscribing to my channel. Likewise, you're more than welcome to leave feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.